graduate at the Sabaragamu University in information systems. His paper ID is 74 if you're following his paper. And so we will have his presentation now. Today. Just bear with us as we have a few technical issues. We'll hear that talk very soon.
I am Tamis Sandagiri from Department of Computing and Information Systems, Faculty of Applied Sciences, Sabaragamu University of Sri Lanka. Topic is detecting crime-related Twitter posts using artificial neural network-based approach. This is the content that I am going to do this presentation. In introduction, security is very necessary aspect of life. Unless we are safe, our most important needs cannot be met. Security is therefore a requirement in human life that helps us to achieve our goals collectively or individually. Crime are a social problem which cost our society deeply in many aspects. The ability to identify unsafe area for crime and identify the most recent crime in a particular location has become a growing concern for both local authorities and residents. Social media platforms are generally consistently provide the user have access to the internet. Moreover, traditional media require time to compile relevant information for the publication, while social media data is generated in real time as event take place. While using social media over the past decade, it opened great part to analyze hidden values. There are such as identifying routing activities patterns, trend prediction, and predict future events. When it comes to the crime domain, social media is one of the fastest and accurate media to notice crime news. Moreover, some sort of people publishes content related to the crime scenes. People post their memes with or without knowledge of the exact reason for their post. When it comes to the machine learning term, these contents have huge predictable power. In objectives, primary objective is collect available reliable information to recognize the essence of crime and to assist law enforcement with future crime prediction. In secondary objectives, first, identifying and understand most critical crime incidents that occurred in past years, then discover crime incident and locations with help of the social media message content. Last, understanding crime type for each incident and group them accordingly. This is the methodology. In this figure shows the overall methodological framework used the study. First, Twitter posts are extracted using crime-related keywords. Then, pre-processing techniques are applied to clean the dataset. Next, Twitter posts are transferred into vectors to generate the features vector in the data preparation step. Then, artificial neural network-based model is constructed to classify the data set. Next, identified crime location using Twitter content. When considering the methodology, data collection. In data collection, Twitter posts are collected through a set of search API of Twitter. The search of Twitter posts must be based on the set of keywords that can be used to clarify the crime situation. Then, Twitter posts are labeled based on the content used to create the training set. The collected dataset consists of more than 100,000 Twitter posts from 2020 January 1st to 2020 January 31st. In data pre-processing, as a next step, data pre-processing technique should be applied to the extracted collection of data. Since typos, unnecessary items such as URLs and stop words in the Twitter post can be available. Data gathered from the Twitter are often extremely unstructured and noisy. Clean Twitter data are produced by pre-processing technique that will be used in next step. We detected stoppers like is, which, is, have, etc. The words convey no positive or negative signification. So, without affecting the meaning to the message, we can easily remove the stop words. We deleted then URLs, hashtags, symbols, usernames, terms, etc. Next, combine words with tokenization technique. Finally, we use stemming algorithm to simplify the word to a stem that contains suffix, prefix, or word group. Some tweets may contain text that seems irrelevant to the process of an analysis of semantics. Candidate makes such as URLs response to other users frequently occurring the stoppers are consist noise. To remove such unwanted content, a noise reduction method was used. In data preparation, after completing the pre-processing, Twitter post the feature vector. The vector are used in a learning place of machine learning algorithm. Here we use word embedding technique to create the vector. In word embedding, every word is represented as n-dimension dense vector with numerical representation. The technique allows word with similar meaning to have similar representation. In machine learning, we can train our embedding model with a given corpus, or we can use any pre-trained word embedding technique to perform NLP tasks. There are several types of pre-training word embedding techniques such as word-to-vec. Word-to-vec is a statistical method of efficiently learning of standalone word embedding from a text corpus. In this study, we use global vector GLOVE for word representation word embedding technique. It is an extension of word-to-vec model of learning word vector efficiently. GLOVE consists of 50-dimension vectors and was generated from 2 billion of tweets, which is far larger training dataset than the collected from our own. The following are the main steps we followed here. In sentence vector, after completing the pre-processing, Twitter posts are converted in sentence vector according to word vocabulary using one-hot encoding. After having experienced different length of sentence, we update all sentence length as 50. If sentence have more words, we extract word have been removed. When they are less than 50 words in sentence, we use the alternative method of zero padding to fill missing values. It iterated through each tweet until the expected size was achieved. In dense vector, the next step is to load the GLOVE word embedding and then create these vectors that contain the words in our crops on their corresponding values for GLOVE embedding. When constructing the artificial neural network-based model, the input layer is created based on a word embedding method. We use a flatten layer to change the shape of the data from embedding layers vector of 2D metrics into the correct format for a dense layer to interpret. Then we use a dense layer with 8 nodes as a hidden layer. In the output layer, we only use one neuron and it will be available since there is a unique output value corresponding to the classification. The training of the neural network is performed using a training data. The integer sequence list is represented by a features contained in the 2D matrix, and the vector that contain the classes configuration parameters are presented in this table. The classification is the output generated by a neural network which, through a training phase, allows to classify the prime label for a new instance from a set of input features of an instance. In geotagging, the last step is analyzing these to extract the geolocation from the post on Twitter. This module has two main steps. Location terms for the post are extracted and the country from the condition for the location extracted, we use the PAC library to extract the word association with the location. It is software library open source for advanced NLP. Afterward, we pass the word to location IQ API to detect the country. In result, we use accuracy and recall to measure performance for our approach according to the below equation. The efficiency of the model is determined by measuring accuracy. Accuracy is the number of tuples accurately categorized according to the formula. The recall is the fraction of the total amount of relevant instance for that were retained. Where TP is the true positive Twitter post, Fn is a false negative Twitter post, Tn is a true negative and Fp is a false negative Twitter post. Following Twitter posts are few examples of the crime-related posts that are correctly classified by our model. Neural network training is the process of fine-tuning the weight and bias from the input data. The optimization process updates the weight parameters to minimize the loss function and calculate the model error. The loss function gives a brief understanding of model errorness with the numerical representation. It helps to improve better models. This figure shows the variation of loss for training and testing data set. The final neural network model achieved an average loss function of 0.345 on the training dataset and 0.267 on the testing dataset. The performance of model is evaluated through accuracy as well. This figure shows the variation of accuracy for training and testing data. The final model achieves an average accuracy of 0.903 on the testing dataset and 0.933 on training dataset. This figure is exhibiting the test data curve is aligned with the training data curve, which means our model works well with new data. Then we constrain accuracy and recall of the proposed model with support vector machine SVM approach. The SVM is state-of-art classification system that used in learning algorithm based on hierarchical risk reduction. The suggested neural network approach, according to the finding in this table, outperforming the SVM-based approach. As we explained, the geotagging module identifies the location-related term in the corresponding country. The following example will reveal the function of the geotagging module. We faced some serious limitation in the geotagging of posts. One of them was the post itself contained more than one location-related detail. The following post explain the issue mentioned. In the first post, France and German are location-related terms. The geotagging module returned the German and France as the final output, which will affect our word analysis in our future works. Another issue with geotagging is some countries and locations have two words in their name. Therefore, the geotagging module sometimes missing extracting the location. In the second example, Puerto and Rico are considered as two words, so it could not extract the location-related information from the post. In conclusion, the paper is investigated the effectiveness of neural network-based approach for detecting the crime from the Twitter post. To evaluate the performance of our model, we used a dataset that collects the historical information of crime indicates in the world. To compare our model, we used a SVM-based approach. The highest accuracy and recall values were obtained by a neural network approach. Accuracy and recall values were increased by 1.8% and 10.4%. In future works, we plan to categorize the filtered Twitter by crime-wise. Then, we hope to validate our Twitter tweets with news posts. Finally, we also plan to implement a crime prediction approach using a deep neural network approach. These are the references that I used in this presentation, and thank you.
Thank you. you very much. I believe Sandhagiri is here to answer any questions. We have a few minutes for asking questions and getting answers. First, I have to thank the presenter for being doing this. I think this is probably this medium probably giving a better chance for people who are presenting for the first time, because you can record and present. So the Q&A is going to be the challenge, but let's interact with the presenter and the author. You can raise your hand, or you can unmute and ask a question. So let me get us started by asking. I think you had made a very good presentation. There was one piece of information that either I missed or you forgot to mention, and that is how you got about how you didn't tell us categories and
do some kind of literature review on the past. I mean, there are some past research paper done in using the crime prediction. So I studied them as well. Then I studied the past 10 years crime or past years crime incidents happen in the world. So I selected the most recent 5 type of crime for the label and identify categorize according to these labels.
But obviously you can do that for 100,000, right?
Yes, but for the I selected the most recent 5 because when it become the label getting
yeah. How many data points label?
actually I first I labeled 5. I mean I selected 5 labels. Then according to each label I selected the related keywords term for each label. Using these each keywords I search from the using Twitter API. So I do some assumption according to that. This each label has set of keywords, and each set of keywords contain Twitter posts are related to that crime type, label crime type.
Okay, so from the 100,000, how many fell into those 5 categories?
Actually, after using the first in this model, I use for a binary mode classification model. It's a crime or not crime. After using that model, I get around only 10,000 of Twitter posts, because most of Twitter contain noisy things. For example,
Yes,
when it comes to
correct. I think that anyone who has worked with Twitter has realized. So 10,000 out of which how much was marked as crime and how much was marked as not crime?
There are 350,000 are marked as a crime, like that.
350,000.
Sorry, there's a 200. I mean, this with the use of the all 100,000 Twitter posts, crime related posts are 10,000, and other 90,000 are the not crime type.
Sorry, I forgot to ask you to have your video on. That would be good for people to ask you questions and respond. Can you have your video on?
Sorry?
Please, others,
Sorry.
can you have your video on? Others can ask questions from the author. seems to be not any more questions. So let's thank our speaker in our usual way. You'll have your microphones on, otherwise he won't hear it. Thank you very much.
Yep, thank you very much.
Okay, so we move on to our second presentation. We have a good gender balance here. First, the talk is going to be on identifying irrelevant question answering systems. And to make the presentation, we have Dinesha Lahiri Pereira. And she has a BSc in Computer Science from University of California and is currently working at Synapse Systems as an associate software engineer. She says she enjoys doing research in the areas of machine learning and natural language processing. So we will first hear her talk, and then I will ask her to the question and question answering part, Q&A.
Hello everyone, I'm Dinesha Pereira and our research is about identifying irrelevant answers in web-based question answering systems. So this is the content of my presentation. Through the introduction, I'm going to introduce you what we're going to solve through this research and the previous approaches to solve the same issue through the literature review and the steps I have followed through the methodology, then the results and discussion, finally the conclusion. In our day-to-day life, we have seen many web-based question answering systems like this. If we deeply go through these systems, we can see two main categorization of them. This chart shows the web-based question answer system categorization according to the way that they generate answers. The first one is answer retrieving systems, where answers are retrieved using a knowledge base automatically. The other one is CQA systems, where answers are supplied by humans using their knowledge and experience. The systems like Stack Overflow and Clora are some examples for these communication answering systems. There we have seen many answers with minus scores, which means they are irrelevant answers. And also we have seen actually the surveys have found irrelevant answers in answer retrieving systems. So in both of these systems, there are irrelevant answers. If we look at the other categorization of web-based question answering systems, it is based on question answer types. The first one is factoid QA systems, where they expect a short answer for a given question. Usually it can be a name entity or a short sentence. The other category is non-factoid QA systems, where they expect complex and long answers for a given question. It can be a description, opinion, or an explanation. CQA systems are an example for this. In CQA systems, the users may tend to provide irrelevant answers because they have lack of knowledge, lack of time to prepare answers, and due to bad intentions such as making fun or spams. So it's a must to remove these irrelevant answers from these systems, since it is highly affect on user satisfaction and the system's efficiency. So to resolve this irrelevant answer problem, we are going to solve that issue through solving 3 research questions. For that, we have used most popular deep learning architectures in QA literature, which are CNN and LSTM, and also we have used a combination of both, that is CLSTM. Through the first research question, we find which is the best deep learning architecture to find irrelevant answers in non-factoid QA. Through the second one, we find partially relevant answers in non-factoid QA. We considered this as a separate goal because the previous researchers have failed to identify this category with higher accuracies. So as the third research question, we are finding irrelevant answers in factoid question and answering systems. If we look at the previous approaches, the main approach they have taken is answer re-ranking. Through answer re-ranking, it don't remove irrelevant answers from these systems. So in CQA systems, it is inefficient because irrelevant answers are still remain in the system. And there can be situations where all the answers may be irrelevant. So there's no point of re-ranking irrelevant answers. And since these systems are highly manual and need high user involvement, the correct answers may be provided in later. So until that, they have to re-rank irrelevant answers. So it is inefficient. And in answer retrieving systems, you may feel that it is a good approach because all the answers are retrieved at once. But the problem is, surveys have found that the answers in these kind of systems are less reliable and having subjective relevance. The other approach taken in CQA systems is answer quality tagging. As I said, the researchers on this have failed to predict partially relevant answers correctly. So in our research, we solve all of these weaknesses, and we suggest to eliminate these irrelevant answers from these systems using our deep learning architectures. As in a normal machine learning process, we have collect data, then pre-process them, and training. Training is happened under 3 deep learning architectures, then testing, parameter tuning, and we get the model with highest accuracy as the best architecture to solve the particular research question. When talking about datasets, we have used 2 non-factoid datasets and 1 factoid dataset. Semivel 2017 and Semivel 2015 are non-factoid datasets which are initially created to re-rank answers in CQA systems, and WikiQA is a factoid dataset which is initially created to identify answer sentence and triggering questions in IRQA systems. Although they have different initializations to different researchers, the answers of these datasets have categorizations such as good or bad or potentially useful, so that we could use them in our research. As you can see, we have used Semivel 2017 to address research question 1 and Semivel 2015 to address research question 2 and WikiQA dataset to address research question 3. This table shows the number of QA pairs in each datasets. If we look at this graphically, you can see that Semivel 2015 and WikiQA datasets are highly biased. Here, Semivel 2015 have less number of data in partially relevant category, and WikiQA dataset have less number of data in relevant category. So to address this biasness, we have used text data augmentation. Actually, text data augmentation is still in the research level, but we have used a simple synonym replacement method in our research. This is the process of data augmentation. First, we separate the training dataset and get the QA category with fewer data. Then we have get the original answers from them. So after removing the stop words, we replace arbitrary selected number of words with synonyms, and we add the original answer and the original label to the created answer and add into the training data set, less amount of category to reach the other level of categories. As an example, if we get the WikiQA dataset, you can say that this is the original dataset, and this is the state after removing triggering questions, and the final state shows you the state of the dataset after adding augmented data. Then other than data augmentation, for the data pre-processing, we have used following steps: extract data from XML files, removing hashtags, contractions, links, stop words, unnecessary questions in WikiQA datasets, answers less than 4 words, because non-factoid answers should have at least one sentence, and drop missing values and non-English values, converting text into lowercase, converting text into matrices, and padding matrices. Here, converting text into matrices is happened under data embedding. For data embedding, we have used two techniques, glow and word-to-vec. Here we consider word level embedding than character level embedding, because words are the most important to extract semantics from the words. So these two libraries are able to extract words from extract semantics from the words, so that we use both of these libraries in our research. When considering CNN and LSTM architectures, they have same kind of architecture, but here in CNN there are CNN layers, and LSTM there are LSTM layers. Both of them get embedded questions and answers as the input, and then go through CNN layers or LSTM layers. Then the outputs will be concatenated and input to a MLP and get the final output. In the CLSTM model, the embedded questions and answers are first inserted into a CNN, then the concatenated output will be go to a LSTM, then to a MLP, and get the final output. Here the architecture get by interchanging these two layers, CNN and LSTM, was not able to predict categories accurately. So this was the best combination of CNN and LSTM we got in this research. In parameter tuning, we have tuned learning rate, batch size, number of neurons per hidden layers, and number of epochs. For reduce the overfitting problem, we have add dropout layers, L1, L2 layers, and batch normalization layers. As I said, we have used two representations, input representations, glow and word-to-vec. When talking about the results, this table shows all the highest accuracies we got for each model. And if you look at when addressing research question 1, finding irrelevant answers in non-factoid systems, CLSTM have the highest accuracy for that. Identifying partially relevant answers in non-factoid systems, CNN have performed better than others. But if you look at the ability of identifying partially relevant answers, you can say that CNN and CLSTM both have performed in the same level. If you compare these accuracies with the previous researchers, you can see that our models have higher accuracies compared to them. This is because the previous researchers have failed to identify partially relevant answers correctly, and we have able to do that successfully. So that actually it is mainly because of the data augmentation, and because of that we have higher accuracies for the second research question. And in final one, again, CLSTM model have performed well in identifying irrelevant systems, and all of the accuracies in this table are obtained from the models which use GLOW because the models which use GLOW has highest accuracies than the models which use word-to-vec. Because of that, as I said, the table contains all the values from GLOW models, and without data augmentation, the biased datasets will not be able to predict the categories with fewer data. And also, as I said, in the combination of CNN and LSTM, adding CNN first and then adding the CLSTM was able to give high accuracies. From that, we can say CNN are able to extract features from embedded inputs better than LSTMs. And as a limitation of this research, I can say that it not cover all the area of factoid QA, because the dataset we have selected have not answers with one word. The WikiQA dataset at least have answers with one sentence, so that it is a limitation, and we try to address that in future. As a conclusion, I can say that CLSTM architecture performed well in identifying irrelevant answers in both factoid and non-factoid QA compared to CNN and LSTM, and we suggest to use this architecture in web-based question and answering systems to eliminate irrelevant answers. Thank you.
Thank you for another good presentation. I will ask Dinesha to put on her video so we can ask her questions. And to start us off, I think Dinesha, like Sandagiri, you have used word embeddings. And so to start off the questions I will ask you. So since word embeddings give you embeddings for different words, how did you get the sentence or paragraph or the post embed for that?
Sorry, I didn't.
Okay. Yeah. So the word embeddings give you embedding for each word, right?
Yeah.
Yeah. So how did you then make an embedding for the post itself, or the question, which is at least one sentence long?
We first do the tokenization, then we of the text. It can be the answer or the question. Then we add it to the embedded layer, and through that we do that.
Yeah. So my question actually is, so because I think a lot of researchers want to know how you kind of either average or do whatever to get sentence embedding, or in the case of an answer which is more than one sentence, maybe answer embedding or a paragraph embedding. Did you use anything
yes.
like Doc2Vec or did you just?
Yeah, I used Word2Vec and GLOW embedding models both, and GLOW has the highest accuracies than the Word2Vec models.
Okay, any other questions? In Sri Lanka, we are very not very good at asking questions, partly because some people think that we are putting the speaker into trouble, but actually we are not putting her into trouble. We want to find out more about how things she did, and it's very good. She took 3 different data sets because one data set was not adequate to answer all her questions.
Yeah, Dinesh, can you hear me?
Yeah, I can.
Yeah, so can I know how many new records generated with the augmentation technique with one training instance?
No, in there, we first get the training data set, and as I showed in the presentation, there are bias data sets, bias categories now. Then I separate that category. Then I get the answer from that, and then I have checked with different values how many words I should replace with synonyms. For that, I use WordNet library, and this is happened to the all the data in that category, and I decide how many times I should do that until it get the level of data in other categories.
I think he wanted to know, so how many, the actual numbers.
It is, I look at the training data sets, how many data in there, and then I look at the fever data.
Yes. I think, Dinesh,
I
I
get
think
the average.
what he wants to know is, let's say that I think DBpedia, we couldn't see that, sorry, not DBpedia, you used something else. We couldn't really see the number. You had printed the numbers, but it was not clear how many were in each class.
Okay, I'll explain the method I do. Think there's 1,000 QA pairs in.
I think that part was clear. Dinesh. That part was clear. He wanted to know.
Yes.
I think because some people are trying these methods and they are having probably data augmentation, as you mentioned, in text is not so well established as in image. So he wanted to get some idea. I think practically speaking, how much can you do it? So like, is it like one was 100 and the other was 10, or one was 10,000 and other one was 1,000? So get a feel for how much you can do that successfully. So in your 3 data sets, I think mainly it's the second and third data set you had to adjust, right?
Yeah.
So let's say if you take that wiki data set, so the irrelevant was very big and relevant was very small. Right?
Yeah.
Irrelevant was the big category. So how many irrelevant were there, so that we can get an idea, and how many relevant, so that we can get a rough idea how much you increased.
Yeah.
In actual numbers.
Yes. If we think there's 100 QA pairs in irrelevant category and 10 QA pairs in relevant category, then we have to iterate it 10 times until it reaches 100.
Okay.
Any other questions? Any other questions? Otherwise, we will thank the speaker in the usual way. Please put your microphones on and let's give her a hand. Thank you very much.
Thank you.
So that brings us to our third paper ID 96 papers. Combinational acoustic models and identifying the impact models in Sinhala speech recognition. And to make that presentation, we have Buddhi Gamage, who is an undergraduate at the University of Colombo School of Computing doing computer science. His research interests include machine learning, deep learning, language processing, mainly focusing on speech recognition for low-resource languages. So I will ask his talk to be played, and then we will have a Q&A session with him. We seem to be having a small technical issue. Just bear with us. So the organizers have decided to give us a short break, and so maybe 2 or 3 minutes. Just hang around. If you want to have, I don't know, a glass of water or something, or washroom break, this is the time to do it. We'll just don't log out, just stay online. Can I check if Buddhivida is here?
Yes, sir.
You're here. Okay. Right. Okay, good. So when we do the Q&A, you can have your video camera on.
Sure, sir.
Maybe while we are waiting, any questions or observations on the two papers we had or the keynote? We might as well make use of this time to enhance our knowledge a bit. I think sometimes we, when we describe our data, we have to, I think the previous speaker, she was very clear in the data sets she used, but sometimes if you don't know what semi-valley is or the DBpedia or one of those, then it may be a little bit of an issue. But she was good. She showed what the what the classes were, and I think that's really important. If you're doing a supervised learning task, we need to tell people not only about the text data that we are working with, but also the class labels, the categories that we want to, it's a classification task we are dividing to, so that people have a good idea of what the task is. Also, I think in the models, in the model use, it's good to try and give some idea of the architectures, especially if you're using a deep learning model, then it's important to describe the architecture so that others may be able to get a better understanding. Of course, the papers will, should probably contain that information, but sometimes it's also good to say that in the presentation. I think somebody, I don't know if he's still here. First speaker, somebody, are you still here?
Yes.
Good. So, so this is not part of the Q&A, but I mean, while you are waiting, as you said, Twitter data has a lot of noise, right? So, from the 100,000, you said that you were using those search words that you got from the literature, you got 10,000, which means those you assumed are related to some kind of crime or not, some kind of crime or the other, and the other 90,000 you assumed are not crime. And so then, how did you, deal with the problem that Dinesha said, which is class imbalance?
Actually, first for the train the data set, first I manually select. First I'm going through. I collected 100,000 tweets. Then I manually check what are the tweets contain incident or not. Then I manually label them crime and not crime for the some set of Twitter posts. It's around 4,000 Twitter posts or 5,000. Then I use that data set to the trained model.
Okay, that's good. So I think because some of the participants should be aware that there's a bit of hard tedious work, right, to do
Yes.
that manually. I mean, 4,000 you would have spent quite a lot of time. Did you get some others to help you annotate, or only you annotate?
Only me. It took me around 1 week to go through the manually and classify to the two classes.
1 week is okay, but that still must be continuous work. And in many cases, I think people will need to get some help from others to increase the data set. And then in that case, you have another problem, which is that not all raters. So Sandhagiri got over that problem by being the only rater. But if you have multiple annotators, then you need to worry about what is called the inter-rater agreement. And if that is like not more than about 75%, then you need to drop those places where they don't agree and so on. So yeah, data annotation can be quite a challenge. In the case of Dinesha, she was lucky because all the data sets were completely annotated. And some very complex annotations, questions and answers. But these are the typical problems that we have when we go for a machine learning based solution, right? Compared to the earlier models, which were rule based or some other models. So I'm hoping that we will have our technical issues solved and the next talk played. So far we had first talk on kind of really noisy data, Twitter post. The second one on some very well collected, collated, annotated data set, but on a complicated task, which is question answering. And here it is to identify irrelevant answers. And now we are going to have one on speech recognition, which is, of course, something that has kind of been a little out of our reach, Sinhala, so far. And so we hope we will hear from the next speaker some ideas about. Also, I hope he will give us some idea about the data. In all these data-driven kind of modeling, the shape and details about the data are really, really important to convey, and not only the models. So sometimes people are so thrilled with the models that they explain all the models, but they forget to mention what the data was and how they collected it and how they annotated and so on. So it's important. So even if the presentation doesn't have, I hope the speakers will be ready to answer that Q&A. Okay, so we are ready to play the next paper, and I ask the speaker to be ready to have the video on for the Q&A after that.
Hi, this presentation is about usage of combinational acoustic models and identifying the impact of language models in single speech recognition. I am Buddhi Kamage, and other co-authors of this paper are Dr. Andil Pushpanand, Dr. Van Veerasinghe, and Dr. Thirin Nedunkodage. And this paper is presented on behalf of Language Technology Research Laboratory of University of Colombo School of Computing. First and so forth, what is an ASR system? Mainly in an ASR system will give the text form of a corresponding speech utterance. In a statistical speech recognition system, it will split the wave file into 25 millisecond features, which is known as acoustic features. A collection of these features will make a phoneme. Phoneme is the smallest constructor unit in a sound system of a language. Collection of these phoneme will make a word of a language. This model is created using hidden Markov model, we will known as HMM model. And probabilities of features to make a phoneme will calculate using Gaussian mixture model, we will known as GMM model. When we use deep neural network to calculate the probability, then the probabilities will called as phone posteriors, and model is called as GMM HMM model. This is the acoustic model of the SR system, and we need two other models to create the SR system. They are pronunciation model and language model. Pronunciation model is the mapping of words with corresponding phoneme sequence. Language model is a probability distribution or sequence of words. We need these three models to make such SR system. In single speech recognition, we can identify following characteristics. Even though single language is a whole language, when it comes to digitally available resources, it is under-resourced language compared with language like English and France. And its speaking sounds of words are varying, so it have highly inflectional vocabulary, and also it is a highly morphological language. Currently, there are no public domain open source speech recognizer to transcribe speech utterance, and available systems are domain specific. In year 1988, first GMM-HMM model system is created for English language. After 23 years, first continuous single speech recognizer is created using utterance of single speaker, but its performance will drop identifying utterance of another speaker. So from that research paper, open the doorway to for single speech recognition to create the single speech corpus and pronunciation models, which is done in year 2013 and 2018 respectively. These are the initial steps in the history for creating public domain ASR system for singular language. Even though available resources are limited, so we went to create a combinational acoustic model using both subspace Gaussian mixture model and deep neural network model, which is discussed in this paper, to address the low resource problem by taking the best out of what is currently available now. Creating the ASR system, we used Kali toolkit, which is commonly used in this domain and have higher resource for the architecture we use for the paper. In our research process, as mentioned in the paper, feature extraction is done using 13 malfrequency Septra coefficient with default for every 10 millisecond with 25 millisecond Hamming window. Then morphone training is carried out, and after that triphone training. After that we do triphone training with the element of monophone training. 3 triphone training models are created. First one is created using delta feature computation, and second one with using maximum likelihood linear transformation with linear discriminant analysis, and third one with speaker adaptive training by doing feature space maximum likelihood linear regression transformation for each speaker. Above each model need to create the subspace Gaussian mixture model and deep neural network models. 2 deep neural network models are created using Keras DNN recipe and Dance DNN recipe mentioned in Kaldi. And we selected the Dance model for the combination with GMM model because it have the higher resource than the Keras model. Using minimum Bayes Rix decoding, we create the combinational model SGMM and DNN model. These are the steps that I followed in creating the ASR system, and they are data preparation, creating necessary files, corpus and dataset creating, training and decoding. Speech corpus was being created by UCSC, LTRL, and recording was being gathered using 2 softwares, PRAT and RedStart. PRAT data had 16,000 sample rate and RedStart data had 44,100 sample rate. Automation scripts have prepared for data preparation alongside with the quality. 2 sets of necessary files need to be prepared, and some of them can be created using available scripts, and others need to be done by own. Here, lexicon, non-silence font, optional silence font, and fonts are representing the pronunciation model of the SR system. Single transliterator software mentioned in single G2P conversion paper is used with changes to applicable with quality to create the pronunciation model. And other files are represented the data preparation of the acoustic model. We had a corpus created using active learning method, and Ngram language models was created using SRILM toolkit. For the dataset creating, I had to find a suitable test dataset in corpus. For that, I created a graph by connecting similar sentences of caller sheets, and using breadth-first search algorithm, I searched disconnected components. Though I couldn't find a set, we had to create a separate dataset for the testing. Overall, we had 30 hours of training data with 78%. Training scripts are influenced by Timit's example in Kaldi, and many more articles and examples had to be referred to develop the training and decoding scripts. Speaking of the results, we trained our acoustic models by differentiating the sample rate and with increasing size of language model to identify the impact with acoustic model. And we observed that increasing computational time and machine power usage in a great manner, though it gives higher results. 31.72 is the lowest word error rate we achieved through the experiment. I created a single speech-to-text application with using the trained models, and it runs in Ubuntu environment. These are the few decoded utterances in the application, and we can observe that the system is well performing in identifying number readings and news readings. Reason was speech dataset gathered in news context, and style of the utterances are not like day-to-day speaking. So variety of the data is necessary for creating ASR system for public domain. 31.72 word error rate is the currently best in single speech recognition, but it is not state-of-the-art results expected. Improvement in corpus and speech dataset is identified, and in domain of like end-to-end neural architecture for single speech recognition is highly motivated to have better results in single speech recognition in future. Thank you. Hi, this presentation.
Okay, so Buddhi, can you have your video on for the Q&A? So we are, so the author of that paper is here. Please unmute your mic and ask any questions.
Can you hear me?
So what is the deep neural network model you use for your research? The structure?
Structure is I use two deep neural networks and selected the best one. The two deep neural networks are created using scripts in Kaldi. They are Keras DNN and Dance DNN. In Keras DNN, there are we do pre-training and then cross entropy training and sequence training, optimizing by minimum base rates. So there are 11 frames and 40 dimensions, and in dance DNN the model is creating two hidden layers, and first layer is 40 input dimensions and with 9 frames, and the 40 dimensions are increased to 360 dimensions. That is the model that models that mentioned in the CALD to create the DNN. These are the basic configurations mentioned in the CALD.
I'm Rohana Tilakumar from SLIT. I have one question. What do you mean by this word error rate? WER is word error rate, saying 32%. That means 32% of words uttered are wrong, is it? Or you said you said best one is 79%, so that means 79% of words are in error or correct?
Sorry?
Now you said best result is 79% word error rate, but that means 79% is in error or 79% is correct? It must be
79% is correct word. We usually in speech recognition we calculate the word error rate. That is the basic criteria to get the accuracy of these models. And word error rate should be minimum, like to at least 2% likewise to get the state of the art results.
What is the state of the art word error rate, like English language?
English language, like there are many corpuses like WSAJ and library speech. Library speech corpus have, I think, 900 hours. Here we only use 30 hours of data, and English language achieved 1% word error rate for it using deep neural network. I mentioned about end-to-end architecture. These are the new domain in speech recognition. So in that using with high variety of data, we can achieve to that state-of-the-art results.
I think we hope.
I think we should appreciate UCSC putting a lot of effort on this matter, which is very important thing for us, and being very humble and honest about their research in their paper. I have read the paper. Thank you very much.
Yes, I need to add something more, that in currently there is research for transfer learning to address the low resource problem. So I think in near future we can have a better models with currently available data also.
Yeah, so I think one of the big things that happened with deep learning is, I did for English, the state of the art was also about 20, the word error rate, and before deep learning. So most of the machine learning methods only had word error rate to about 20. So the last few years, you can see how that came down to 1%. And the other thing, I guess, is that word error rate means if you get a single phone wrong, then the word is wrong, right? So if you say labanna, but you get labamna or something like that, then that's wrong. Right? So I think it's quite a strict accuracy measure. And even long before we get to 1%, I think we have usable systems, right?
So can't we now correct that kind of error using kind of language model, another one using the like scriptgram or something like that?
So that's so Buddhi's language model is supposed to do that.
Yes, language model mainly have a better impact in with increasing the size, but it is another aspect. It is hinder the computational power and it take much time because with the increasing language model, it will create a bigger finite state transducer to decode our utterances. So in when we talk in deep neural network, that the language model is and pronunciation models all are in a single model. Here in statistical architecture, there is 3 models. So that is the one thing that hinders the computational power. So
Also, I think my example was not good. I'm trying to think of a good example. So yeah, so it won't get the kind of example I said. I think it won't get it wrong, but there are many other places where both are possible words, and it gets the wrong word. I think we may have to move on. Thank you, Buddhi. So let's thank him in the usual way by unmuting and clapping, please.
thank you.
Okay, so we move on to the next paper. It is paper ID 78 for those who are following papers. And the topic is CNN and RNN LSTM based hybrid approach to detect state-of-the-art stance-based fake news on social media. And to present it, we have Pathum Gunatilaka, who is a final year software engineering undergraduate at John Kotalawala Defense University. And he is also a mentee for something called Scholar X class of 2020 at Sustainable Education Foundation. And maybe even Q&A, we can ask him to say something about that. And he's currently a trainee software engineer at 99X. So we'll first have his presentation played and then have him come on live for Q&A. I think we don't have the sound, right? Can we have the sound, or is it a live presentation?
No, sir, actually, it's a recorded one. I think it should have sound. I have tested
Okay.
it also. Yeah.
I think we'll have to go back and play and check the sound. I think something wrong with the sound channel. Give us a minute to see what's wrong with the sound.
Hello, sir. I think it is working well. I think there's a problem with the, I think the presenter who is present in the screen currently. Yeah.
Sorry, I was on the phone to the people there. What did you say? Some people can hear the sound.
No, sir. Actually, I checked from my end in the Google Drive. It's working fine, but the presenter currently who is present in the screen, I think they don't have sound to present the paper.
Yeah, I'm trying to get through to them, but okay, I think we got the message. Hopefully, we'll have it replayed.
The fifth one, fake news pattern detector, has used technologies like CNN,
Can hear
identity,
it.
web,
Can
feature
you play from the
extraction,
start?
fact
Can you play from
extraction
the start?
techniques, is a deep learning network that detects the patterns in fake news. And for the sixth one, is BS detector, is a browser extension to search about unreliable sources, uses technologies like data scraping, web syndication, etc.
Hello
As
there.
for the
Sorry to disturb. Can you start the
related web,
presentation from the
Can
beginning?
you start from beginning?
uh, for the fake news. Hello everyone. It is really honored to be here at ICTer 2020 conference. My research is about CNN RNN L-stream based hybrid approach to detect state-of-the-art stance-based fake news on social media. My name is Pathum Gunatilekar and I am a final year software engineering undergraduate at General Surgeon Kothara Defense University. Okay, let's move forward with the presentation. This is going to be the content of my presentation. Content of the presentation includes introduction related with problem statement, then solution, after that hypothesis and aim and objective of the research, then research methodology, software process model I used to develop the system, then the hybrid deep learning model, after that the implementation, then future work, and finally references. Let's start with the introduction. Today, out of 8 billion people worldwide, 3.8 billion people are social media users. With the advancement of new technology, more and more people are moving towards those social media platforms. Due to that, people can easily get to know about the things which are happening around the world just surfing through those social media news feeds. Because of the freedom and simplicity gives from those social media platforms, anyone can express anything at any time, and this helps to create and distribute fake news comfortably through those platforms. Due to that, people find it difficult to choose between what information is right or wrong when surfing through those social media news feeds. Okay, these are some of the related work I have found under the fake news detection topic. First, Hoaxy. They have used several technologies in Hoaxy like data scraping, web stream integration, Toit API, and scrapey spider techniques. Hoaxy is an online tool that can collect and track misinformation and fact check, and then visualize those misinformation on social media. Then second one is fake news tracker, which uses several technologies like feature extraction, LSTMs, autoencoders, web scraping, and web crawler techniques. Is a tool that collect, detect, and visualize fake news on social media. As for the third one, is Defend, a fake news detection system that provides explainable user comments on Twitter and gives news propagation network, including trendy news, top terms, and related news. It also uses several technologies like web crawler, Foxy API, web scraping, and different algorithm, etc. As for the next set of related work, News Verify is real-time news verification system that can detect the credibility of an event using several technologies like feature extraction, sentiment analysis, web scraping, web crawling, and Truth API, etc. For the fifth topic, fake news pattern detector has used technologies like CNNs, word embeddings, word-to-vec, feature extraction, fact extraction techniques. It's a deep learning network that detects the patterns in fake news. And for the sixth one is BS detector. It's a browser extension to search about unreliable sources. Uses technologies like data scraping, web syndication, etc. As for the third set of related work, for the fake news detection module using in-time analysis, they have used several machine learning techniques like stochastic gradient descent, support vector machines, and STM, KNN, decision trees to get the word-based engrams to represent the context of the document and generate the features to classify those documents. So the eighth one, for the detect fake news on those social media network, basically they have used fake machine learning classifiers, biasnet, logistic, random tree, and ways to detect and filter out sites containing false misleading information. As for the final set, they have used several deep learning techniques like CNN, LSTMs, and combination of both CNN, LSTM, CNN, GRE, and they have explained the effectiveness of those embedding techniques. And finally, for the trace miner, they have used LSTM-RN model to provide high classification accuracy in real-world dataset. As you can see from those related work, there is still not a matching mechanism to detect fake news. And let's move forward. This is the problem statement I have found. Most of the time, due to the lack of verified news sources and fact checkers on social media platforms in Sri Lanka, social media users have failed to identify fake news stories in their news feeds. Because of that, people are sharing those news stories on social media platforms without checking it, and it leads to spread a lot of misinformation through social media platforms in Sri Lanka during the last year. And these are following real-world examples prove the above problem statement. As you can see from these examples also, it enhances the above problem statement really well. And this is going to be the solution I am going to propose from my research study. Developing a hybrid convolution neural network, recurrent neural network, long short-term memory-based deep learning model that can check the reliability and credibility of local and international social media posts and find between real and fake news stories using the verified news sources around the world. Basically, it's a development of CNN, RNN, LSTM-based fact checker. As for the hypothesis, develop a high accurate deep learning model to detect fake news articles and social media posts that can serve as a tool to help social media users to find between real and fake news stories in social media platforms. And for the aim is to minimize the effort and time to check the validity and credibility of social media posts using modern technology mainly for social media users to stop spreading misinformation through social media platforms. And these are the main objectives of my research. It starts from developing a deep learning model to detect fake news spreading through social media, and it helps to reduce the time and effort to check the validity and credibility of social media posts. And it also helps to make awareness to the users by notifying misinformation spreading through social media. Finally, my target is to develop a unique platform for Sri Lankan social media users and traditional media users to discuss their opinions on those social media posts and news published daily, and also developed a crowdsourced fact checker to get the Sri Lankan people to one platform. This is going to be the methodology of my research project. It all starts with data collection plan. For the data collection plan, I have created a separate data set called Sherlock Fake News Net. It has 216,000 news articles on websites like snopes.com, politifact.com, bbc.com, news.lk, afpnews.com, FC Sri Lanka, gossip.com, and I have used Twitter API to gather social media posts as well. Every news collected from reliable news sources are labeled as 1, and every news collected from unreliable news sources are labeled as 0. If the user input the text as the Malika website comes under cyber attack, then from the hybrid model, it checks and gives a message as verified news by showing the text in green color. If the user inputs a message like all the universities and schools remain closed for 2 months due to the coronavirus outbreak in the country, then from the hybrid model, it labels as a fake one by showing the red color with the text. Later, you can see the implementation of the research. As you can see from this diagram, I have started the research with collecting the data set. After that, I have built an NLP data pipeline to remove special characters, stop word removal, tokenization and stemming limitization step to improve the data set. After that, I have built a deep learning neural network from starting the first layer of the neural network by using love word embeddings. Then I have used convolution layers and max Boolean layers to extract high-level features from the input data. Then after that, L2 LSTM network have used to track long-term dependencies of the input data. Then dropout and dense technology used for the final step to improve the efficiency of the deep neural network. This is the main software process model for the proposed research project. Basically, data are collected from social media posts and verified news sources. Then it stores in a database. Then after that, building the deep learning model, it will check those posts and post with the model, and if it is verified news, it's show as here, and if it's fake news, it's show in red color. This is the hybrid deep learning model of my research project. When it comes to hybrid deep learning model, it consists with convolution neural networks, neural networks with LSTMs. And for this research project, I have used Adam optimizer as the optimizer and binary cross entropy loss function as the loss function. And after dividing the data set into training size 90% and test size 10% with 10 epochs, here are the comparison of results for different models. As you can see from this table, from the proposed hybrid model, I have achieved the highest accuracy rate of 92%. Here you can see, after that you can see the diagram for training and testing accuracy for the hybrid model. And from the right side, you can see the evaluation, precision, recall, and F1 score for the proposed hybrid deep learning model. And as after that, you can see the confusion metrics for the hybrid deep learning model and heat map results also. And finally, I go one step further and implement a mobile app called Shell. These are the main features of mobile app, and my research is used as the fact checking feature of my mobile application. As you can see, if it's a real news and real social media post, if it will show in green color as here, and if it's a fake one, it will show in red color. And for the conclusion and future work, we can see after 10 epochs with DEM optimizer and binary concept and tropic loss function, from the suggested hybrid neural network architecture, we have achieved 92% accuracy with the available dataset and research work carried out in this trans-based fake news detection area. Therefore, we can conclude that the proposed CNN RNN LSTM-based hybrid approach achieves the highest accuracy of 92% by surpassing most of the classical models today. And for the future work, hope to run this hybrid model on transformers like BERT. And after that, hope to do some experiment with federated learning APIs as well. And with that, hope to publish the dataset in CAGDA dataset for further experiments. And finally, this research will be maintained as a public GitHub repository to update the results get from time to time with the new experiments in the dataset. And these are the main references I have referred for my research project. And thank you very much, everyone.
Thank you, Patum. Thank you for putting your video on. Let me keep this Q&A session with my questions. So I think one of the things that we always have to worry when we do machine learning and deep learning is figure out what actually the model is learning. So since you are you are auto labeling, right?
Yeah.
The data was, let's say, maybe you assume that AFP and certain news sources are reliable.
Yeah.
And then you said you also got some Twitter data, right? I'm assuming that's not from AFP or Reuters or BBC, right?
No,
those are
from separate data.
So my question, like say in Sri Lankan news, there's a guy called Asama Amin, right? Will he be auto-labeled as unreliable, or how will that happen?
Okay, sir. When it comes to data collection in my project, I have used several reliable sources and most of the government news sources like news.lk to collect the dataset. And when it comes to those fake news related stuff, I have used, there are a lot of fact-checking news websites like AFP News, and those snopes.com also I think have those features. They have mentioned what are the fact-checking news stories, and they have published the news stories with whether this is a false one or a real one. From that, actually, I have got those data and labeled it as fake one. And all those news getting from reliable news sources like news.lk, I have labeled as ones. Yeah, I think I answer your questions.
Okay.
So
have a question.
how you evaluate that? So the system detect as fake. How you know whether it is a really fake news or not?
Okay. Okay, so, when it comes to detecting whether it's a fake news or not, from the hybrid neural network architecture, in our data set, there are separate two classes. For one is for the social media post or news headline, then next one is label. For those two classes, I have used binary cross entropy loss function because it's a kind of a binary classification task, and from that I got with Adam Optimizer, I got results for whether it's a fake one or real one. Actually, when it comes to real world scenarios, it's quite difficult to identify with the new kind of fake news and data creating recently. For that, the thing is with the new data, hope need to tune up the neural network for that actually. Yeah.
I have a question. In one of your graphs, two graphs you presented
Yes,
for
sir.
the accuracy.
Yeah.
So one is for training and other one is for testing. Why is the accuracy changing when you are testing data? So when you are testing, it should have the network should have converged, right? So it should show a constant accuracy. I would have expected in one of those graphs.
I think, sir, the thing is with the data set, when it comes to the data set, only 112,000 data are real, and the fake are 104,000 around. When it comes to dividing those to 90% and 10%, from random selection, they are checking whether it's a fake one or real one. But when it comes to training and testing accuracy, I have got around for the training set accuracy 94% actually, and testing accuracy 92%. I think with the data set that problem occurs actually.
So your graph.
Do you have balanced data set with you?
Not well balanced one. Pretty much into like I mean 60 to 55% to 45. I think. Yeah.
So basically, I have this question now. If you take one particular sentence, whether say Amitabh Bachchan has got COVID-19, so that could be a fake news as well as a good correct news. So how could you train a neural network to automatically identify without labeling manually how to identify such a statement as a fake news or real news? That's my concern.
Okay, sir. When it comes to those scenarios, data set need to be updated with the latest news updates. From that, actually, our neural network learn those are the scenarios with the data and what are the things we need to test with our data set, our hybrid neural network actually. I think for that need to have a data set update over time.
So basically, you rely on some reliability of news source to basically to mark this as a real or fake news. No? So that is what is given out by your neural network. It doesn't have any intelligence to decide on its own whether it's fake or not.
Yeah, actually, it's kind of a classification problem here. It can classify it whether it's a real one or a fake one currently.
Can't we use a rule-based method rather than using a neural network, because you already identify the real good sources and bad sources, no? Initially.
Yes, yes. I think it would be a good approach, but for this this scenario, I have used this approach with the literature I have found for this result prediction. I think I can hopefully go with that approach in future. Yeah, thank you for the information, sir.
Thank
I
you.
think all the questions brought out one aspect, and that is that neural network may be learning to distinguish between the sources rather than the messages, and uh, that you can find out by trying to see what are the features that it learned. The features are like AFP or SNOPs or whatever, then you know it has learned those rather than actually the content. So
Yes.
you can, I mean, if you're going further, you can also look at some network-based methods for establishing credibility and things like that. But overall, I think we should thank the presenter and also for being here for the Q&A. Thank you very much.
Thank you very much, sir. Thank you very much for the opportunity. And small thing to mention, I hope to continue this research for the Sinhala language as well in future. Hopefully, I can contact with NLP group of UCSC to continue with my research. Thank you. Thank you for the opportunity. Yeah.
Okay, that brings us to the last paper. Can I first ask whether Rajita is here, the presenter of paper 28?
Yes, sir. I'm here.
Right. So the last paper is titled Sinhala and English Document Alignment using statistical machine translation. To make that presentation, we have Mr. MDC Rajita, who is an undergraduate at the University of Moratuwa, Department of Computer Science and Engineering. So we will first hear his speech and then have a Q&A with his video on. So till then, you can keep your video off, but after you play the video, we will have the Q&A. Final paper.
Hi. Our research is Sinhala and English document alignment using statistical machine translation. I am MDC Rajita from Department of Computer Science and Engineering, University of Moratuwa. Machine translation systems have shown impressive performance, and the performance of these highly depend on the training parallel corpora. Document alignment is an important task in generating parallel corpora. A lot of researches have been done on document alignment techniques for high-resource languages. But these state-of-the-art techniques were not tried out on Sinhala language, which is a low-resource language. We explored the performance of a hybrid document alignment system for Sinhala language and improved upon that. First of all, we explored on existing literature for document alignment and we were able to identify four main techniques. In one technique, the metadata such as URLs, hyperlinks were used to find the similarity of document pairs. Since such metadata is not available in all the dataset, the technique is not universally applicable. The next technique uses previously gained lexical knowledge in the form of a machine translation system or a multilingual dictionary. Translation system, but the performance of the system is highly depend on the accuracy of used translation system. The third technique is the latest technique and it outperforms the state-of-art techniques. But these neural embedding-based systems is a data-hungry approach which requires a large amount of data. When it comes to low-resource languages, the performance reduces largely in these systems. The last technique we identified is the hybrid systems which combined above mentioned techniques and try to improve the results. Our proposed method is inspired by the Yoda system, which is the best performing technique at WMT16 task. It is a hybrid system based on a statistical machine translation system and translate the source documents into target language. Then the similarity of document pairs was calculated using cosine similarity of inverse document frequency weighted n-gram vector. We explored this method and we added 4 improvements on this baseline system. When we use the SMT system, we found that those SMT system was trained on government document and our data we used for our experiment was extracted from news websites. Therefore, after translating these documents, there were about 50% of Sinhala words in the translated document. To reduce the number of Sinhala words in the translated document, we applied a dictionary on top of the translated text. This method was able to reduce the number of Sinhala tokens in the translated documents. And Sinhala language has many words which were originated from English language. Therefore, transliteration can be used to get the English words of the most of the Sinhala words. So we applied transliteration on the remaining Sinhala words. But in some cases, transliteration may not give the exact English word, but almost similar. Therefore, we used character similarity to identify the best English word for the transliterated Sinhala word. The following table shows some examples of this transliteration, and let me take the first example. The Sinhala word capital was translated into English as Kapital, but the actual English word is Capital. But since this gives a higher similarity value compared to other English words, the English word capital is selected using this similarity measurement. And then stop words are the words which are highly occurring in the documents and which contains no meaning. So we removed both Sinhala and both English and translated document. So we removed stop words from both English and translated Sinhala documents. The following table shows some examples of the translated sentences we use. In the second column, you can see the machine translated documents contains much Sinhala words with English words. Therefore, we use this dictionary, and finally, using transliteration, we were able to convert the Sinhala document into a fully English document. This diagram shows our method, and the improvements we did for this method were indicated in yellow color. The source documents were translated in using a baseline SMT system, and the output contains partially translated text. Then we applied a dictionary and a transliteration used to this output text, and then we improve the output translated documents using character similarity. And before calculate the similarity, we removed stop words, and then after that we calculate similarity using cosine similarity. This table shows the experimental results of our system. We used documents from 4 news websites: Hero, News First, Army News, and ITN. The leftmost column shows the recall values for our baseline system, and we were able to gain about 10% improvement for these websites except for Army News. For Army News, the baseline system also showed about 97% recall value, and we were able to, although it shows good result, we were able to improve those results using our method. Thank you.
Thank you. I think we have a very short time for Q&A, but very quick question. Maybe I will ask one question. That is, Ajita, now when you, in the last table of accuracy, actually not accuracy, you said recall, right? What do you mean there by the recall? So the baseline SMT system had very high scores. What does recall mean then?
So we manually aligned, we crawled data from these news websites. Then we manually aligned some of these data, some of these documents. That means most of the news websites publish English and Sinhala news at the same time or within the same day. Then we manually aligned some of these data, and then we check the recall value with generated from our system with those manually aligned data.
Recall means what?
Recall means what percentage of our golden alignment. That means how many sentence pairs were selected from this document system from out of our manual alignment.
And what is SMT? I mean, you use SMT, you said?
That means SMT is used to at the beginning we translated all the Sinhala language documents into English, and then calculate the similarity values and find the best which is suitable for the translation.
So the SMT model was built using
we used the existing SMT system. From that, we translated all the Sinhala documents into English, and
what
then
is testing system you used? Which one?
That was CETA system by NLPC of University of Moratuwa that I have mentioned the paper in this the paper. I have cited the paper. It's,
It's because for signal and Tamil, I mean, we usually use something called blue score, right? The score, and you can never get into 70s, 80s, 90s. Usually, those scores are like 20s, 30s, maximum 40. That's why I asked, but MNT is a big difference. Yeah, I think unfortunately it would have been a nice discussion, but we will have to close there because I realize that we are our session has gone.
One more question. Sorry, sir. That SMT is available for outside views?
I think it's not. We have requested through email and get it.
Okay. So let's thank the speaker in the usual way by unmuting your mics.
Thank you, sir.
Thank you. And so that brings us to the end of this session. As you know that this session was going to be very long, and so we divided it into two, and we were supposed to have a half an hour break or something like that, but there is no break I think now, but there will be a different session chair. So once again, I want to thank all of you for waiting patiently and supporting us, especially deal with some of the technical issues. And I thank Kavinder and Lakshani and Angana, the people who have behind the scenes helped us with running the session as smoothly as possible. Thank you. See you on the other side with the other sessions and the keynotes.
Thank you, Dr. Veerasinghe, and the authors who presented. So now we can move on to the next item in the agenda. So we have two parallel sessions, session 1C on NLP and session 1D on distributed computing and physical computing. So, and there's a special announcement for best paper selection committee members. So it will be highly appreciated if you can join the 1C NLP session. And thank you for joining this session. Hope to see you in the other sessions. Stay safe.